Imagine you are given a random signal that is made up of multiple unknown sine and cosine functions, and you're told to find what combination of sine and cosine functions match the unknown signal. This is a pretty daunting task, and for very complex signals, simply guessing and checking is unfeasible. Thankfully, there's a solution: the Fourier Transform, an equation that can help us with this task. The Fourier Transform is represented by this equation. With this, we can map the signal to the frequency domain, where frequency is the x-axis instead of time. And wherever there are peaks in this graph, it will correspond to the various frequencies within the complex signal. For example, if the transform signal showed peaks in the frequencies 2 and 3 Hz, then the unknown signal must be made up of 2 sine waves with frequencies 2 and 3 Hz. With this in mind, there are many uses for this technique. But before we use this transformation in real life, we must change a few things. First, we use the formula for the discrete Fourier transform, which is basically the Fourier transform with a finite set of data values. But large datasets are computationally expensive, so we use the fast Fourier transform, or the FFT, which is an algorithm which can compute the DFT very quickly. It is this algorithm that is used in many applications today. For example, imagine if that unknown signal was a sound wave from a microphone, and in that sound there is some frequency that you want to get rid of. You can use the Fourier transform to turn the signal into the frequency domain, remove the frequency you don't like, then reverse the Fourier transform, giving you the desired signal, a knowing frequency removed. This isn't the only use though. Want to take an MRI? You'll need the Fourier transform for that. Want to create realistic water for your video games, as seen here? You can use the inverse of the Fourier transform to take multiple sine waves and turn it into a big ocean. And finally, think about this very video. If you're watching this, the Fourier transform has probably been used to compress the image into a smaller, easier to manage file size, so you can watch this video faster and easier. And with just a single math operation, you can see how it makes the world go round, and how it has and will change our lives from now into the future.